We're going to have a little discussion around data, right? Typically, when we talk about AI, we go very either deep into the models, share stories, and there's a little bit too, I would say, a little talk about actually what fuels learning, which is data. And that's what we're going to discuss a little bit right now. Before I start, maybe a quick round of introductions. So, I'm the co-founder of CityAI. I'm also a venture partner at a fund called OpenOcean. So we invest in Series A stage startups with data-intensive startups. So that's also why my interest in data is there. Very short, maybe Geert?
Yep. My name is Geert Vos. I'm the co-founder of Media Distillery. I'm also there the CTO. I have a background in software engineering. I have a master computer science. And after my studies, I did multiple startups. Last one was not Media Distillery, because that one's still going on, but eBuddy, instant messaging, and now Media Distillery.
Hey, my name is Edwin Poot, founder of EnergyWorks, started in 2012. We are processing large quantities of data for the energy sector. There's a huge need there in not only the data quality element that we're going to discuss hopefully, but also getting value out of data. So during our lifetime, we started out at Amazon, and later we went over to Google. So maybe I shouldn't say this here, but we have a very close partnership with Google. We work very closely with the Cloud ML team as well. So hopefully today you will enjoy what I have to say. Thank you.
My name is Jurgen Sandig. I'm the former CEO of Cypher. I was co-founder of Cypher, and that was an AI company founded in 2014 and sold it in 2017 to Qualcomm Technologies. And I'm currently working as a research director for Scale Up Nation, where we do fundamental research, why companies scale, and some other stall. So that's my background.
Cool. So maybe we can start a little bit about the different stages, right? So I would love to touch a little bit on data access and your lessons learned there. It's also something that startups struggle often with, either to create the right data or get access to the right data somewhere. Then you mentioned already data quality. So what are the issues there? What have you experienced? What can you share back? And then also, I think, data cleanup, all that stuff. Would love to zoom into this. Already talked before a little bit with you guys. You mentioned some, customer cases where you have some good examples. So maybe Geert, maybe if you want to start, and we start a little bit about data access. So what, were your experience at the beginning? You also mentioned a bit synthetic data that you guys used. So maybe you can walk us a little bit through what you guys did and what you learned from it.
Yeah, sure. Yeah, I forgot to mention it in the introduction, but Media Distillery is a company that focuses around the analysis of video in real time. So we apply all kinds of machine learning algorithms on live streams for customers worldwide. For example, Red Bull is one of our customers, and for them we are doing real-time logo detection in video. So we do soccer games, but we also analyze social media videos found on the internet. And the problems that we face there are mostly that we take a state-of-the-art algorithm that we find in the literature most of the times. We try to apply that in the real world with real data. And we see that the benchmarks that you normally find related to literature are completely off compared to when we apply the real data to it. So the thing that we have to do is, of course, take the data that matters to us and train the algorithms on that or fine-tune it on that. The good thing is we have access to large amounts of data because we process lots of video. So within a few seconds we have thousands and thousands of images that we can use for training. But we need to label it, sort it, and make sure that it works well. So yeah, one of the lessons learned, what we do is we often start with synthetic data to make sure that our pipeline works, make sure that the algorithm can be trained and we are ready for it. We label the data with Amazon Mechanical Turk, for example, majority voting. And then we start training or fine-tuning our algorithms, and we can apply it on large amounts of data to see how it really performs.
So maybe what are the challenges, using synthetic data in the beginning? Did it work from the start? Like, did you have to figure stuff out, or what were the challenges?
Yeah, what we notice is that the synthetic data does not work at all to actually build a working algorithm. It only works to actually test your pipeline. So you know that everything is implemented correctly, things work, you can detect stuff. But since it doesn't look like the real data, the algorithm will not perform well when you apply it on real data. An example that we did was text in the wild. So we wanted to be able to detect text on t-shirt, these kind of things. So the first thing that we started with is just generating large amounts of synthetic data, trying to make it look like real data. So applying motion blur, applying JPEG compression, introducing artifacts. And it works to train your algorithm, but in the end, it's never similar to your real data. So you always need real data.
And one more question. Do you think it could actually slow you down? So not taking this properly into account, do you think companies that create synthetic data actually might make it much harder for them in the beginning if they don't realize the impact on the models?
Yeah. I think it's very important that you realize that synthetic data will never, or that it's very hard to create synthetic data that actually looks like real data. I would only advise it for testing purposes and making sure that the things are working. But if you have access to real data, go for that.
So how about you guys, Edwin?
Well, when we started, I was working on the energy trading department of a large utility in Europe. And one of the biggest challenges there was volatility of data. So data was changing quickly, and everyone was using Excel sheets, saved on file drives, changed by colleagues. No one knew it was changed, etc. So at some point, they were trading on commodities, and they made mistakes, and no one knew where it came from. So one of the biggest challenges we saw there first was, okay, the large quantities of data, the volatility of data itself, and how can you spot weirdness and other elements in the data, like noise maybe, or bad configuration. So what we did, we built something that allowed us to inspect the data automated and skill as well. So for example, to evaluate individual data points. What I forgot to mention is that we process a lot of time series data. So it's not a lot of object structure data, but it's more like time series data. Currently we're processing over 20 million data sources per day for many customers. We have one standardized platform, one baseline of code where all customers are running on. So when we create something like validation rules, as we call them, the customer can plug them in. We can spot gaps. We can spot like anomalies, for example, during this process, and we flag them. We annotate those values and during this process we calculate the data quality score. So we have like a key performance indicator, which is like a weight average index score of every element in the data set. And then we correlate it also with context. So because we believe without context, you cannot evaluate the data properly. For example, when do you know when an anomaly is a real anomaly in the data? Did something happen? For example, a few weeks ago, I was talking to a customer. They actually asked us to ingest TV programs information. So we can actually see, hey, there's some spikes here. People are at home watching the TV. So there are a lot of different elements that have impact on the load shape in our case, because we're talking about the time series. So that was the biggest challenge for them. And according to Gartner, for example, they say they're like around $10 billion a year spent on data quality. So the biggest challenge is getting all those rules, all those elements and algorithms in place to discover what's wrong with the data. And once you found it out, then there are two things you can do. You can fix it, or you can go to the source and tell the source, hey, you have to fix your data because otherwise you have to fix it. So one of the things we ran into with another customer here in the Netherlands, a large grid operator, their timestamps of their data loggers were shifting 1% every day. So they were looking at a certain timestamp, but it was not actually the timestamp they were looking at, and no one knew about it. So when they asked us to evaluate the data, they found out it had to do with the firmware of the data loggers. So there was a big fix for them because can you imagine that you control your grid based on the wrong situation or wrong moment in time. Another example I can give you is, for example, we did a case for the detection of hot sockets, as they call it. So smart meters have sockets where three phases are connected to. If they're not properly tightened with a screwdriver or by the mechanic, they could potentially catch fire, melt and catch fire. So the customer asked us, can you detect and predict which ones are likely to be candidates so we can go there and fix them on time? So they gave us like 500,000 data sources, 500,000 meters of data, but only 13 occurrences of the last 10 years. So we built a model, of course. We tried to train the model, but yeah, the model was not accurate enough. So it was easier to sort by temperature in the end. Quite simple algorithm, right? Than using the machine learning model. But over time, because I told them, well, you need to gather much more information of false and true positives, so we can label the data. So over time, this model can perform. So that's also a good and a bad example, maybe on how, when or not to implement like machine learning kind of capabilities. So in the end, when we have all the data pre-processed, then they finally can run their models. They can get value out of the data, and instead of putting garbage in, getting garbage out, they get actually real accurate results. And yeah, we have a lot of benchmarks and metrics to measure the accuracy of the models. In the time series industry, you can actually use the time series in the historical, from a historical perspective, and then apply the actuals to it. So you can actually measure the accuracy of your model, for example, for predicting in terms of load forecasting. Yeah, and that works out pretty well. So that's a little bit about my 10 cents on this. So yeah.
Thanks so much, Jürgen.
Well, I've a small extra to add to it. I like actually the example you just gave. We were working on a forecasting model and liquidity. We were at a big bank. And then we found out after almost 95% of the project that all the financial data was not in dollars but in different currencies. So we trained a model and it was completely rubbish. So the lessons learned was that you should really be close to the subject matter expert guiding you through the data, because that's really an important one. And then adding or applying a simple model, a linear regression, or even sorting it like the temperature, that's also good to just get to know the data, because you have, when you start with an advanced model like you do based on a paper, and you have new data, then you have two uncertainty sources. That's the model and the data. So try to fix one, know your model, and then run it through the data. So in order to get to learn all the insides and outsides of the data, and look at it very critical, and discuss the outcomes with the subject matter experts to find out whether you see some strange artifacts in the data, because that is really killing you actually. And then also from the labeling part, that is, we did some interesting projects with the visual defects in the steel. And then we found out that the training set we used to train the operators was actually quite not representative for the actual work they did. So you get a wrongly trained model, and that doesn't work in practice. Also, another thing is that when you find out that the actual work that has been performed and use it as label by the quality inspectors and absorb this information, then you also found out there's no common understanding of what's good and what is bad. So if I present you those images and train you, then you all have certain different opinions on whether this is problem A or B. There's a big difference between humans, how they interpret the data. So if you train your model then on the user input without refining those data sets by one expert or a referee, then you might also get into trouble with the real good quality of the model. And then you get into a real strange discussion and say, well, the customer will tell you the model sucks, and then you say, well, your data sucks. That's not a real good conversation to have with the customer. But that's a serious issue, because the customer is not aware. Actually, you're both right. The model is good or sucks, so that's quite a fight then. Actually, so be aware of this information or the situation. Also, people might game it. That's also quite an interesting one. People want to frustrate your product because they're also afraid of what's going to happen next. That's what we actually found out in some of the projects, that if you use the user group as an input for your model, then you see a lot of strange things. Be aware there, because people might also frustrate your product.
So, just curious, was it intentional? So, I mean, often with IT departments, for instance, that they want to stay in power. Let's say people certain positions don't want to leave. Was it that certain people were actually manipulating the data because they were afraid that they would lose their position potentially, or?
Well, there are some aware and there are some not aware. So if they are aware, then you have a serious problem. But also we did in bone segmentation, CT scans, where people segment manually the bones out of the images. Then it's also that people are really convinced that they say, well, this grayscale is bone and it's not bone. And if you look at it, they say, well, there's actually no grayscale at all. It's actually the same. So you just infer it like humans infer things. They see things that are not there. And then you also have a difficult discussion, say, well, I don't see it. So do you see it? Yes, I see it. Well, that's also hard. And it really affects the quality of your algorithm. And this is really a hard problem to solve, actually.
So one of the things we noticed when we're talking to customers, they don't know simply what the quality of their data is. They have a good feeling about it. Sometimes they have a hunch that feels good about it. But at some point we ask them, okay, who owns the data? Are the data stewards? So how is the data governance organized? And they haven't thought about that before. So even though you implement like an automated model with a lot of machine learning, data quality checks, etc., if someone is accounted for and responsible for that data, and if something is wrong, you can actually pinpoint it to it and say, hey, you have to fix this. It's your responsibility. So what we did also, when using the system and when validating data, mistakes are made by the models because they're not accurate enough. But people then tend to change data manually to improve it. So, and if you record those changes and those actions in the GUI, for example, we can build another model that actually trains based on those elements and changes and adjustments they make on the data. And at some point, then the model can say, hey, every time with this kind of load shape that's weather sensitive, they tweak this and this and this. So let's do it next time. And then ask, like Google is doing on Inbox maybe, or some other app, would you like to do it automated next time? You know, those kind of things are very important as well.
Anything to add?
Yeah, maybe it's something on a completely different topic, but actually to create more data if you have only limited access to data. One of the things that we did in the past a lot is actually data augmentation. So we work with visual information a lot. So for example, images can be rotated, cropped, flipped, grayscaled. You can add all kinds of noise to it. Adding motion blurring to images. That actually helped us a lot to build more resilient algorithms that could do better detections on a wider range of images. While the data set was actually quite poor and limited, but with some creativity, you can actually build a huge data set and do a lot more training on it. Yeah.
So let's zoom into the data quality bit. I mean, you already touched upon it, but also with media distillery. So what were your lessons learned there? You know, what did you pay attention to? What would you have done differently now?
Done differently. Well, one of the funny cases that we did is we wanted to grab some attention as a company. So we launched a website during the Olympic Games, the previous Olympic Games, to automatically track your favorite athletes while being on TV. So we were ranking all the athletes based on airtime. And I think 3 days after going live, we noticed that all people with the darker skin were all classified as one of the same marathon runners. And apparently we had a huge racial issue built into our algorithm. And this actually has to do with the data set being very homogeneous. So there's a lack of black people in our training set, and you immediately see it back in your results. So that was actually quite painful. Yeah.
So whilst we're on data bias, actually, so how, for instance, also I talked to Ramzi from IAM, and he mentioned the same problem that they have, also exactly with this, like, you know, races, and initially the recognition was quite poor. He also mentioned with labeling, for instance, because I mean they categorize a lot of pictures. You know, people label those pictures, and then they get into issues where, for instance, in German, Kind, right? In English, it's kind. So they get into all these kind of issues with labeling as well. I mean, in your case, like, how do you label the data? Is it also to some extent like crowdsourced, or I assume? I mean, how do you guys do it?
Yeah, some cases we use, for example, Amazon Mechanical Turk to have images labeled by multiple people all over the world. We basically do some kind of majority voting to build in some automated checks. And this is how we can build large data sets. Sometimes it's more complicated. For example, we're also training Dutch politicians. Sometimes I don't even recognize them. So that requires more skilled people actually to train your models, and that can be quite expensive. So for that we have a pool of students that we use for labeling data, and there we also use augmentation tricks to actually inflate our data set to have more material to train on. Otherwise it would be too expensive. And we have of course access to large amounts of live data. So we also built actually smart algorithms that help us train. So for example, we can just run a base face recognition algorithm on TV and just collect all the faces that we see, cluster them based on similarity, and then ask one of the students, okay, is this cluster all the same person and who is it? Because if a person is often on TV, he's probably well known. So then we, in one go, have a large collection of images of this one person, which actually helps us scale the training process.
How about you? I mean, in terms of labeling data, you know, the data quality, any other issues that you guys had, or what you would do differently now?
Yeah, so the difference with time series data is if you want to label it, that's a very tedious job, especially if you talk about like 6 millimeters. We have a customer in Portugal, 6 millimeters, 15-minute intervals every day. Okay, I wouldn't see people labeling that. So we have built algorithms that can do it automatically, and we use a lot of historical data for training the model. But just one thing, when you were talking, one thing came to mind. A while back, we did a project in California, Berkeley, where we read all data from a sensor called microsynchrophasers. They produce up to 30 to 100,000 values per second, and there's around 1,700 of them. And the cool thing of that thing was you could put it, for example, in a hotel room. You could see what your neighbor was watching on TV, because the signature that it produces on that fine-grained data was able to discover what channel you were watching. So when we were processing this data, we could actually train the model to detect those kind of TV programs. So maybe not directly which program, but you could at least say they're watching the same program because the signal is the same. And then you have a lot of channels in the US. You have, unfortunately, a lot of channels to match. So that's
So you know who's watching porn, basically.